record button 3 times before the record. But that's all right. Those prevent errors. Okay. And forgetting, I think I know now. But the camera just kind of automatically zooms itself back when you start recording. Doesn't make any sense. Still, that's all. Okay, so we got x squared minus 3x minus 28. That's the possibility. 28 is 28 times 1. It's negative 28. So I know that the one possibility for the two numbers here are negative 28 and 1. Now, it's not going to work. If you multiply that out, you're going to get like negative 27x. So it's one you can kind of dismiss after you've practiced several of them and after you see how these things work out. Okay, so that's not going to work, but I'm listing it anyway because you might need to list everything. Okay, you don't want to miss anything at first. And then, of course, it could be x minus 1 times x plus 28. With a minus on the 1 and the plus on the 28. It's got to be a minus and a plus because you have minus 28. You got to multiply the negative by positive. Okay. So now both of those, neither of those possibilities don't work out. You can see right away if you understand what you're doing here that this is going to give you a 28x and this is going to give you a minus 1x. That's going to give you a positive multiple of x when you have a negative multiple of x. So really the number you have the plus on should be less than the number you have the minus on, but you don't always see that at the beginning. After you've done a dozen of these or so, you start seeing these patterns. And maybe you see them right away. Just depends. Different people quicker seeing this than others. Okay. Then we have maybe x minus 2. Well, let's do x minus 14 times x plus 2. And then just to be complete, we would have x minus 2 times x plus 14. That's not going to work because you're going to have a 14x, which is way bigger than negative 2x. It's not going to give you negative 3. Then you've got x minus 7 times x plus 4. Okay. And it turns out that's the one that's going to work. Then you got x plus 4 times x minus 7. Now I'm assuming everybody can quickly and easily multiply these out using the distributive law. Later on in the problem set that I gave you, I asked you to expand some expressions, okay? And using the distributive law, that's the way I want to see them done. We'll talk about that later. Okay, but, okay, this is, well, that's x squared minus 27x minus 28. So that doesn't work. This is x squared plus 0.7x minus 28. Clearly, that doesn't work. This is x squared minus 12x minus 28, and that didn't work. This is x squared plus 12x minus 28. And if we're thinking maybe we don't even write down the ones with plus is bigger than the minus, we have to have the minus. Okay, I'll multiply this one out. This is x squared minus 3x minus 28. There we go. And this one we don't have to check. It's not going to work. It's obviously not going to. Oh, actually, it would work because I wrote it down wrong. That should be x plus 7 times x minus 4. Got careless after I realized we had the right one there. And that would give you a plus 3x instead of a minus. Okay, so you can always do this. It gets rather tedious, so you want to be able to see in advance whether a possibility is worth writing down. But you want to consider them all. Okay. Now, this is one we actually did in class last time. 6x squared minus 2x minus 20. Now, that could be x here and a 6x here. Okay, that might possibly work. Okay, so if you start with an x and 6x, what are your possibilities? Well, negative 20 gives you a bunch of different possibilities. Okay, so it could be with negative 5 and a plus 4. Or it could be with an x plus 4 and a 6x minus 5. Or it could be an x minus 2 times 6x plus 10, or x minus 10 times 6x plus 2. You see, in every case, I'm just writing down two numbers that multiply out to 20 here, and I'm keeping my x and my 6x right where they are. Okay? And then, of course, I guess I could have started out, I did this in logical order with the smallest divisor first. Okay, so, 20 can be written as 1 times 20, 2 times 10, or 4 times 5, right? Now, we don't deal with fractions, you know, that usually gets to be a little bit more of a pain than we want to really go through, and we usually don't have to do that. I'm not going to ask you to do that in this course. Okay. Well, that's fine, but you know, then we could have 2x and 3x with all these numbers again. Minus 5 and plus 4, 2x plus 4, 3x minus 5, 2x minus 2, and 3x plus 10, 2x minus 10, and 3x plus 2, 2x minus 1, and 3x plus 20, 2x plus 1, and 3x minus 1. Okay. Well, that's quite a few factors, but how long does it take to write them down? 2-3 minutes. Okay. Then you can start looking at them and see which ones are likely. And if you can't tell which ones are likely, you just start multiplying them. Okay. Over here, we're going to get 6x squared. And then the minus 5 is going to multiply the 6 to give us negative 30x. The 4 multiplies the x to give us plus 4x. And I think we end up with negative 26x minus 20. So that didn't work. And we multiply this one out, and we get 6x squared. And then we get 4 times 6 is 24. Minus 5, we get minus 19x minus 20. Well, double check my numbers here. I'm getting confused because I'm doing this kind of quickly. We have the negative 2 and the 6x gives us negative 12x, and 10 times x gives us 10x. So we got negative 10x and 12x, and oh, that's 24. So this one works. So we don't have to worry about the rest. Because the factorization is unique, you're not going to find two different ways to factor this thing. Okay? At least if you factor out the greatest possible monomial, which we'll have to do on the third problem. Okay? So here we had to go through, down to the fifth possibility, and we got this one right. Okay? Here we got up to the third possibility. Now, if we'd have listed these first, we'd have to go through all these and then three of these. Well, that's why you do a bunch of them. You list them, and then you start developing an understanding of what you can pretty much dismiss. Okay? If I started here, I would dismiss this because 5 times 3 is a lot bigger than 4 times 2. I don't want to get a -2. This one I wouldn't necessarily dismiss. This gives me a 12 and a -15. This gives us 6x squared minus 3x minus 20. So that one's one we'd have to check out. Okay. I would dismiss this when you got 20x here and a -6x here. It's not going to work. That gives you a -30x, and that's not going to work. And that gives you 20x, that's not going to work. And that gives you 40x. Most of these you can dismiss. This is one you'd have to probably check out. And that's after you've done a bunch of them and really instinctively know what you're looking at. You have to practice these. And I'm not sure that I put a lot of factoring on the test. Well, I'm pretty sure I didn't because the test isn't going to cover stuff that we're just reviewing today. Okay. Test goes up to like early last week. But that'll be in the final. So I do recommend that you practice it. Okay. Well, this last one. And let's kind of dismiss this one fairly quickly. Because, well, you'll see. You know what I need to do? I need to factor 5 out of this because everything in here is divisible by 5. Actually, I'm going to change the problem. Okay, nobody really got to this, I don't think. And if you did, that's fine. Solved it the way it is, that's good. But I'm gonna change it just a little bit. And I'm gonna observe that now there's an x that's common to all of these. Now there's not an x squared because this x doesn't have square on it, okay? Let all that. But I can factor out x. And also every number here is divisible by 5. It's easy to see that. The number ends in 0 or 5, it's divisible by 5. So we've got 5x. And then it's times x squared plus 3x minus 28. Okay. And then what do? Well, we write down the possibilities. Okay, we'll just write down the possibilities for this. This could be, I'm not going to write out x minus 28 times x plus 1. Okay. Because 28 is going to be too big. It's not going to give us a 3x. So I'm going to actually do a little what I said. I'm going to dismiss it. Really, I could write out all these. Okay. Now this is a plus 3x, but this is a minus 3x, but that doesn't matter. What you got here is a minus 28 and a just plain old x squared here. So I could check all these possibilities and see which one gives us this. And it's going to be actually the last one here. Okay, well, I'm going to write them out in the order I did before, dismissing the one that has 28. And I could actually dismiss this one. so I can do this. I can multiply this out, I get x squared minus 12x minus 28, that's no good. Here I get x squared plus 12x minus 28. And that's no good. I'm not even gonna try this one because I know by negative x, negative 7x is bigger than 4x, that'd give me a negative. So, my general prejudice, get rid of that. And then I've got x squared plus 3x minus 28. And that's it. And then I write my 5x out front. I didn't do that before because I didn't want to confuse things for the entire expression. There it is. Okay. So again, here's a simple algorithm. You just do it. And after you've done several, you start looking for shortcuts so you can make good decisions about which possibilities to try and which ones not to try. Okay? That's the way it works. That's the way I think people usually do this. Okay, well, the time that you have for next time makes use of this skill. So I'm going to use the same expressions that I have here. I'm going to make an equation out of this. X squared minus 3x minus 28 equals 0. And then I factor this. Well, I've already factored it. It's x minus 7 times x plus 4 equals 0. Now, can you tell me what the solutions of this equation are? The first thing I got was 0, and it's not totally unreasonable, but if you check it out, you find that it doesn't work. If x is 0, well, if we plug 0 in, we get 0 minus 7 times 0 plus 4, which equals negative 7 times 4, which is negative 28, so we don't get 0. Okay? Now, when we learn to graph things like this, you will want to plug in x equals 0 because it tells you something about the graph. But as far as finding out the values of x that make it 0, that doesn't work. Also, you could look at the original equation. If x is 0, this is 0, and this is 0. What the same. So you get negative 28 equals 0, and it doesn't satisfy the equation. Okay. So that was a good try, and thank you. But let's try something else. Okay, so another suggestion. How about x equals 11? Well, I asked people to check it out for x equals 11. A lot of people didn't know what to write down. Okay, so let's make sure we understand what we mean. If we let x equal 11, here's our expression. Okay, our expression is x minus 7 times x plus 4 equals 0. So if x equals 11, we get 11 minus 7 multiplied by 11 plus 4 equals 0. Don't start calculating until you have the whole thing written out. Okay, some people got as far as x minus 11, then never did write out 11 plus 4. Okay, here's your expression, here's your logic, and I recommend that when you substitute right now, you write out the logic because I think you need to do that so you understand what it means to substitute a number. It's something that I see people having trouble with the pre-calculus class too. Okay, they don't seem to understand what substituting a number is. Probably because all they do is they look at it, they do something on their calculator, they get an answer whether it's right or wrong, and it was right. Okay, I'm afraid there's maybe something like that. The explanation could be completely different. And I need to do a careful study on 1,000 randomly selected people to validate that suspicion. But, okay, so my point is, we're trying to find a number X that makes this zero. Okay. So this means when we say, what about X equals zero? Well, I assumed everybody would know that we just replace X by zero, we get this, and we don't get zero. Okay. Then somebody suggested 11. So, okay, try it for 11, but most people didn't write it out correctly. Some people did. So again, I suggest you write out the expression. So if X equals 11, we get this, and we get then 4 times 15 equals 0, 60 equals 0. Nope. Okay. So what other numbers might we try? Okay, now I really had to coach most people on writing it this way because, again, I suspect that our mathematics curriculum does not emphasize writing out the logic of anything. Okay. And you really need to do that to understand it and retain it. Okay. So how do you write this out? Because the suggestion was X equals 7. Well, let's see, we got X minus 7 times X plus 4 equals 0. So if X equals 7, we get 7 minus 7 times 7 plus 4 equals 0, or 0 times 11 equals 0, or 0 equals 0. Now you can write these out in steps below. You don't have to write all these ors. Okay. Matter of fact, I should probably write it out that way. Okay, so let's just write it out again. X minus 7 times X plus 4 equals 0. If X equals 7, we get 7 minus 7 times 7 plus 4 equals 0. 7 minus 7 is 0. 7 plus 4 is 0. We get 0 times 11 equals 0. We get 0 equals 0. And yep, X equals 7 is a solution. Now, is there another solution? Or is that the only solution? Now, we don't stop when we get one solution. If there's another one, we look for it. If it's a linear equation, there will be only one solution. But this isn't a linear equation, so there might be another one. What do you think? Okay, now that worked out well. Everybody got it, but most people didn't write all the books. Okay, like this, yeah. X equals -4. Then I didn't write the then up here, but the then is pretty implicit. So I recommend if then X, sorry, -4 minus 7 times -4 plus 4 equals 0. -11 times 4 equals 0. 0 equals 0. Yep. So now we see that there are two solutions. Now, once you understand the logic of it, you can see it, but I really want you to practice right now to logic. So I can say drawing writing is too small to read, flip back room, but by inspection, the solution set is set 7, -4. That's another bit of notation that I strongly recommend for what's up, for what's coming up. Okay, so you might want to make a note of that. Might want to review that. Video, this is where I'm emphasizing some of this language. Makes mathematics much easier. Makes it easier to think about what to do. Makes it easier to see what to do. Okay. Now, there's another way. Write this out. This. Let's now let's go ahead and do it again, but let's do it with this third problem, which was 5x cubed plus 15x squared minus 140. Set that equal to 0. Now that's an equation that you want to solve, and we're going to try to solve it by factoring. This is something, when you get to pre-calculus, you're going to need to be fairly adept at. The whole thing factoring. You don't want to be stumbling over this when you're trying to deal with the nature of the solutions of polynomial equations and stuff like that. Okay? So how do we do this? Well, we factor. Incidentally, if I change this to 141, there's no way you're going to factor. Okay? So that factoring is actually kind of limited value in applications, but it's important for understanding. And you won't understand what I just said until you get into it in pre-calculus. Okay, anyhow, factoring, yes, we get 5x multiplied by x squared plus 3x minus 28 equals 0. So that 5x times x plus 7 times x minus equals 0. Now, normally, and when you do these for homework, I really strongly recommend you write out the logic and the words. It doesn't take long, especially after you've done 2 or 3 times, it becomes automatic. And it takes only seconds. It's not going to slow you down. It's not going to interfere terribly with your life, especially since you're going to learn it better if you do it that way. Okay. So, can you just look at that and tell me what numbers are going to work? Can you write them down on your paper? Okay, again, some of you are picking up on the language here already, and that's very good. Please, everybody, try to continue that, at least through this assignment, so you understand the logic of what you're doing. Okay, but I'm going to skip the logic because, well, we've emphasized it over here. I'm just going to say, by inspection, x equals -7, and x equals 3, our solutions. Because you can see, if you plug in -7 here, you're gonna get 0, and that's gonna make the whole thing 0. And if you plug in 3, it's gonna make this 0. This whole thing is gonna be 0. There's another value of x that makes it 0. Can you tell me what that might be? Show me some fingers. So x equals 0. Okay, show me what happens if you plug 0 in for x. Now that didn't work on the first example, so you might have been reluctant to use 0. But let's make sure we understand why x equals 0 is a solution. Just to remind you the logic I'd like to see you writing up. We have this equation we're trying to find solutions for. We've already done the usual thing and found -7 and 3. If x equals 0, well, that means that we can replace all these x's by 0. So here we've done that. Every x is now a 0. And then we have the 5, it's multiplied by 0, and then by 7, and then by -3. Well, as soon as you multiply by 0, you're just multiplying by 0 until you're done, right? Got 1 0 in there, it's all going to be 0. 5 times 0 is 0. 0 times 7 is 0. 0 times -3 is 0. There's a solution. Now, let's go to the second equation. You find solution. And the equation was 6x squared minus 2x minus 20 equals 0. Okay. The equation would be this. We found that the factoring was x minus 2 times 6x plus 10. Okay. Now the logic. It's going to be true if x minus 2 is 0, because x minus 2 is 0, then you multiply 0 by whatever this is, you're going to get 0. Or if 6x plus 10 equals 0. Because again, if 6x plus 10 turns out to be 0, then the whole thing is going to have to be 0. Is that clear? Should be pretty obvious, but you really want to think about it, you really want to understand this, because you don't want to forget it when you get into a test and have to use it, okay? Or when you get into your pre-calculus class later and have to use it, okay? You don't want to be tripping over this idea. All right. Well, now the way I'm going to write this is, this equation breaks into two equations. So, knowing this, we can break the thing like this. And when you get to equations like this, I recommend you write it out the way I'm writing it out. You don't have to necessarily write this will be so if. I wanted to be halfway literate. You can just write true if. Okay? Abbreviated if. You want the if in there. Or if this or this. This says the same thing without putting the words in. But don't write it out without the words as you've written out the words. So you know why you're writing it out. Okay, well, anybody can show me with their fingers what the solution to this equation is? X minus 2 equals 0. X is 2. You could add 2 to both sides and it'd be done, right? Add 2 to this side, add 2 to that side, you get just plain old X equals 2. So X equals 2. You normally wouldn't need to write out all these steps. Right now, personally, you go ahead and do it. Okay, now can you solve the other equation? Okay, to solve 6x plus 10 equals 0. Subtract 10 from both sides. And you get 6x equals negative 10. Then you divide both sides by 6. And you get x equals negative 10 over 6 equals negative 5/3. Now, most of you do need very significant review before you take the midterm. Because even though you did quite well on the homework when you solved linear equations, most of you can be able to solve that equation. Okay? Now, maybe you just needed a reminder, but the point is, you want to learn things well enough in this course that when you see them later, you don't need much of a reminder. Okay? And solving linear equations is one of those no-brainers. Nobody's going to explain to you how to solve a linear equation in a pre-calculus class. Now, if you do as you probably should do, as almost everybody should do, just take the MDE 61 along with the Math 161, then certainly I'll explain, okay, in the MDE 61. You know, I'll review with you how to do linear equations. I won't spend a whole lot of time reviewing, but give you enough review to be able to do it, okay? So, again, think about how it is you're learning things and try to take my advice on how to prepare for this midterm. And try to put aside plenty of hours to do that, okay? Because you really kind of need to bring this stuff together in a way that's going to help you move forward into the other courses, okay?